This is a Lenovo Yoga 7 16 ARP8. This computer turns on, show the light, then goes off. Okay, let's plug the amp meter. And it's taking 14 volt. The USB-C chip, it's working fine because it's switching from 5 volt to the 14 volt. I did check the voltage in the battery, and the battery has a good voltage. Plus, when I plug the USB-C, the battery voltage start rising. It means the charge is going all the way to the battery. Yeah, the battery unplugged, that's why that orange light is flashing. And let's push the power button. Okay. And you can see the light over there. The computer tries to turn on, then goes off. Okay, let's try again. Yep, you see the light there, right there. Or, yep, let's go off. Randomly, we're going to check the board, see if we can find any short. We go with the medium size capacitors, and we go from there. Yeah, usually this reading is the processor. This is a short, and this is a resistance on the processor. Okay, this is a short in these capacitors. I'm gonna come back for it again. Check the resistance on the coils. That's a CPU resistance as well. Yep, this one. Alright, so let's check here. Could be one of these capacitors is bad, hopefully. Or could be something else, the other side of the board. Okay, so it's shorted here. So could be the short this side of the coil or this side of the coil. But we need to remove the coil to figure out if the short is here or the short is here. And this coil is connected to this chip. Alright, that's the ground side of the capacitor, and this is where it was the short. And look, the reading now is a 0, 1, 2. That's a different reading than how it was before. Is a 15 ohm. So that's how could be is a CPU reading, and how many ohms we have this side. Please, you're coughing. So we check the resistance this side, and here we have 1 ohm. Here we have 18 ohms, and still going up because the board's still warm. Yeah, and if we check this trace, it's connected to this chip, and that chip is look like it has a hole in it. Yeah, it has a hole over there. I'm gonna remove that chip. And let's put the coil back. Or let's check here. Yeah, you can see now the resistance is 7 ohm because the board is still warm. This chip here is a DC to DC converter. Because there is a coil here, so should be that's the output, and this output should be between 1.1 to the 1.8 volt, I think, and the input it should be this big capacitor right here. The input it should be like maybe 5 volt. You take like 5 volt and make it like 1 point something because the resistance here is low. Yeah, 15, about 20 ohm. Or I'm gonna make a search about this chip, this one here, then we go from there. Yeah, the chip is a CWFF-OD. All I find is a CWFF, and that's like a DC to DC converter, and it take 5 volt and transfer it to the 1.8 volt. I'm gonna start with 1.1 volt and keep rising till we see if the computer gonna power on. Yeah, and I can't find that chip. Uh, and I don't have a donor board for this one as well. So set a power supply at like 1.2, 1.1 volt and about like 1 amp. And we're gonna plug the USB-C. It's taking about 14 volt. And I'm gonna inject the voltage to this side of the capacitor right after I press the power button. So it's taking about 200 milliamp. I see the screen is on. Yeah, the screen turns on and goes off. Let me show you right here. And I did see the fan goes on. Yeah, the fan is spinning. And the screen, you can see the light. Yeah, we have the display. Yep. So it's taking 1.1 volt. Yeah, I couldn't find that chip replacement, so I'm just going to use a DC to DC buck converter. Just this small chip. This can sit right there. Yeah, it can sit right there. It is not going to touch the back or anything. Yeah, these tiny wires, you can get them from a screen, from a LVDS computer screen. So these two here is the input, that's the output. And we need one ground. Okay, that's the ground side of the capacitor, and this should be, that's the positive side. Okay, we can plug to there. Ground, we can check it from these two capacitors right here. See, it's connected to the screw hole. Alright, that's the input. The plus is right there and negative is right there. So the output, we don't need the ground. We need just the positive side. But I'm not going to connect the output until I adjust the right voltage for the output. So I connect the USB-C and we check the inputs, how much we have. I'm going to need to press the power button. I need to open the screen because the power button is disabled when the screen is closed. So we want to check the input and the output. See how much we have. And the input, after we press the power button, we have 5 volt. Yep. So 5 volt, stable there. And how much we have the output? 3.9 volt. So we need to adjust it. Alright, here is the input is 5 volt. The output is 1.1 volt. Already unplugged the computer. And we are going to plug that, going to solder the wire to the output. Let's try to power on the computer and see how it's going. Taking 14 volt, the battery unplugged. Power it on. I can see the keyboard light, the backlight of the keyboard. The hard drive is unplugged. And we have the display. The computer turns on, it stays on. So let's plug the, gonna put the heatsink, put the other devices. Okay, I'm gonna plug the battery back. So it's taking 14 volt, 1 amp, and the light is white. It means the battery is full charge. The keyboard light is on. And we have the display. Yep, is loading the system. The Wi-Fi is there, and so the computer is fixed. So that's all for this video. Thank you for watching. Please subscribe and see you again.